Here is a diagram that people use to represent color space. Now, this is weird. I don't really know what it means, except the fact that this big, like, in shape, that's a bunch of colors, right? What those actually are, how exactly they're being represented, what that diagram means, less important, right? Just for now, let's say that it's all the colors that there are, right? So there's all the colors that there are. Now, this square in here, those are all the colors that your camera can capture, right? So that's everything that your camera can record. Now you'll notice it is not as big, right? And that's because the camera can't record all the colors, right? So if I tried to photograph ultraviolet bulb, right? I would see the way your camera would see. If you were B, right, you see color a different way because B is a different set of wavelengths that their eyes are sensitive to, right? So the B color space would be a different color space than the human eyeball color space. Just the camera color space right there is a different set of colors than the whole big wide range of colors in the universe. Does your camera actually look like the square? No, I'm sure it doesn't. But for purposes of understanding what the fuck I'm talking about, this is good. So there's our beautiful raw file. Now, the problem with it is that we go and look at it, let's say, on a monitor or a phone or whatever. And that monitor, phone, or whatever has a different set of colors that it can represent, right? So these are all the colors that can be represented by my monitor. So still a bunch of colors, just not all the same ones. And that means that there are some colors, right, that are present over here in my camera space, but don't make it into my display space. So I've recorded them, but damn it, I just can't show them to you using this monitor, right? Or this printer, or this phone, or whatever, right? So these are those colors that are left over, right? So these are the areas that were not overlapping between that initial square, our recording color space, and our second color space, which was our monitor. Those colors are called out of gamut. So, right, they're a problem, right? You can record them, but your thing can't show you them. The question that we run into then is, okay, well, what do we do with them? So the answer to that, my friends, it depends. So I'm going to show you these three things. They are not going to be relevant to what we're doing right now. Hopefully they will be relevant next semester when we're able to print on campus in the labs. So we'll talk about them, memorize what they mean, and we'll see. So the first thing, right, here is our problem that we had. So we have an image where there is out of gamut color, and I've chosen three arbitrary. I've got a hard time looking what point. And nope, there we go. There, yeah, color over there, and color over there. So we have two options for what we can do with these colors, right? We can shrink that whole square down so that it fits inside of the triangle, right? So we said, okay, listen, like I've got all these colors, I need to represent them somehow. Just like shrink that color space until the whole thing fits in the new color space. Shrink the source color space image until it fits in the destination color space image. Now, then what this means, right, is that all the colors change, right? Everything, it all shrank, so every single color has gone from being one value to being a new value. But colors that were different in the beginning are different now, right? So in this example, right, so here we had these 3 spots in my original square, right? I'm giving you their RGB values. In the new one, right, those RGB values are all still different, right? So there are, it's a smaller color space. We don't have some of the, extremes of color that we did in the first one, but every color that was different in the original is still different in the final one. Now, the other option that we have, right, so that was perceptual, is relative colorimetric, right? So relative colorimetric, you'll see this is, right, the same shape as that original square. The only thing that gets adjusted are things that are bounds, right? So if you have, and it can be both your camera and your printer, it doesn't change, right? It stays. The only thing that changes are the colors that are out of bounds, out of gamut, right? Those colors get brought in to whatever the closest color is, right? So if it's like, okay, before, this, it's hard to point the screen, that thing is super far out of gamut. I'm just going to bring it in, right, to the closest point, the least change that gets me inside of my new color space. So fewer colors change, right? But a bunch of colors that were different become the same. What does that mean? So you'll notice this whole triangle of stuff here, right? That all gets shrunk down to this line. And that means that, say, everything between this dot and this dot, which was a whole range of different colors, right? They all get shrunk down and they're all just whatever the closest value was. So that corner dot was originally 212, 246, 034, and this other part inside of the square was 200, 248, 116. Again, those are red, green, blue values. You don't really, but now they're both the same. All right, so that thing that was out here on this corner was pulled back to the closest point. That closest point, right? All of those outside colors are now this sort of same range of colors. So what that means, if I have a big blue sky, right, and some of that sky is out of gamut, I'm going to pull it back in, and that means it may become flatter, right? I'm going to lose some of those subtle gradations in blues if all of those subtle gradations are out of gamut. They will now be whatever that closest color is, and it will flatten out. So relative colorimetric, right? Fewer changes in color. Some colors are now the same. Perceptual, all the colors change. All the different colors stay different. You will be able to choose these options later on when we're talking about printing, probably at this point in Photo 2. Will you be able to notice a difference? Not necessarily, right? We don't often have, or we don't always have, images that have a whole lot of stuff that's way out of gamut. Most of the time, I just check perceptual and forget about it, right? As long as I don't have things that are way out of gamut, I'm not actually shrinking down that much. And so the fact that everything changes isn't that big of a deal. If I was doing stuff where I needed really, really precise color matching, right? If I'm like, okay, I can get this Coca-Cola red in gamut, right? Then I would definitely want relative colorimetric, right? Because I don't want that color that I've worked so hard to get shifting, right? If like, this piece of bottle over here shifts, fine, right? If this like piece of backdrop shifts over there, fine. But that Coca-Cola red, it had better ruddy stay, as it were, right where I put it. So that is a little bit more color theory. Memorize relative colorimetric, memorize perceptual, what the difference is, how they work, know what out of gamut color is, and you will be fine and more than prepared for next semester when hopefully we'll get to put some of these things into practice. sorry, I forgot one important thing, and that is when we're talking about color spaces, right? So a color space is all of the colors that you have, right? So my camera has some set of colors that it can represent. That would be my camera's color space. My monitor has some set of colors that it can represent. That would be my monitor's color space. It's really important that you know about a bunch of common color spaces that are widely used on devices. The three that we'll talk about are sRGB, right, which we've seen before, Adobe RGB 1998, which we've also seen before, and then ProPhoto. ProPhoto you don't need to know about other than to know that it's bigger than either of the other two. Sorry, flipping you off. Yeah! So sRGB is the smallest of the color spaces, but that means that the most devices can represent it, right? So if it's a smaller color space, you're more likely to be able to see all of it on your phone, your monitor, your grandma's monitor, your printer, whatever. Adobe RGB is a bigger color space, right? And as a bigger color space, right, it's great because it has more colors. We can do more editing. We can do more representing of color. But you're not necessarily going to be able to get all of it on, your computer screen. You're almost certainly not going to be able to get all of it on your computer screen. More likely in a print, definitely not on a screen, definitely not on a phone. That's why we use it for when we're making TIFFs and printing stuff out. It's a nice big color space. We're not going to lose any color when we convert to it. sRGB, we use it because you're more likely to be able to see all of it, but it's a smaller color space that is going to have fewer colors, fewer differences. You're going to have to make a bigger shift, right, as we're going through these things, right? That triangle, right, that's your destination space. So sRGB is going to be a smaller triangle than Adobe RGB 1998. You're going to have more adjustment necessary to take your raw file into sRGB than you are going into Adobe RGB 1998. Again, even less going into ProPhoto. So totally forgot about that. Just wanted to let you know because I am almost certainly going to ask you about it later on.